This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
Okay, I'm going to get things underway. So, for those who don't know me, my name is Simon Dennis and I'm the Director of the Complex Human Data Hub. And so on behalf of Amy Purforce, my Director, and the other members of the Hub, I'd like to welcome you here today for a very exciting event, our very first Pip Patterson oration. I'd like to start by noting that we're meeting on Wurundjeri lands, that we acknowledge past wrongs and that we extend our respect to all members of the Kulin Nation. So the way we're going to run today, we're going to start with Gary Robbins. Gary was the kind of architect of this, and he's going to talk a little bit about the purpose of the oration and our august guest who it's named after. And then Nick Haslam is going to introduce our speaker, Yoshika Shima. So I'll ask Gary to come up.
It's a great pleasure for me to be here at the inaugural Pip Patterson oration and to say a few words about the person after whom this lecture is entitled, Professor Philippa Patterson, who is visiting us today from Sydney University. So welcome, Pip. Welcome back, I should say. And it's not well known to outsiders, but there's a long tradition in the psychological sciences called mathematical psychology or quantitative psychology. It goes back into the depths of the 19th century. And it has its origins in the complex business of measuring psychological attributes and behaviours, but nowadays its scope is much wider. And in that field of mathematical psychology, Australia has actually made a significant contribution, and well above, we're punching well above our weight, I would say. And amongst the many Australian researchers who've been part of that, Pip Patterson is one of the most eminent. Pip did a PhD in this university. It was a joint PhD in both mathematics and psychology. That was an unusual combination then, as it remains to this day. I'm not sure why, but there it is. Pip was interested in what's called network algebras, kinship structures, kinship networks, follow the rules basically of formal algebraic structures in mathematics, which means that you can apply the mathematics to the kinship systems to study them and to compare kinship systems across different cultures. So Pip's original interest in that area led to her being now the preeminent expert in the world on that topic, and her 1990s textbook is still the dominant text in that field. She subsequently went on to develop new statistical methodologies for the analysis of social networks with some very eminent international colleagues. And those methods are at the forefront of social network application today. Throughout this august research career, she's always applied rigorous mathematical and statistical reasoning to complex data sets, not necessarily big data sets, although sometimes so, but complex data sets of high dimensionality like social networks, in ways that take into account good social science and are directed to problems that I would say are of public interest, societal significance. And I think that's the combination that the Complex Human Data Hub is essentially trying to develop and extend. So it is very fitting that this oration be named after Pip Patterson. As many of you know, she subsequently went on to another career in university management. So those of us poor researchers were left to some degree without our mentors and colleagues, although she still has plenty of time to offer words of wisdom. So she was, for a long time, at the centre of management of this university and more recently at Sydney University. So it's for those reasons that we've named this oration after Pip Patterson, those very fine contributions, and I for one would certainly like to acknowledge her contributions that have led to us all being here today. Thank you, Pip.
It's my enormous pleasure to introduce today's Pip Patterson orator, Professor Yoshihisa Kashima. And I honestly can't think of a better person to speak about this topic, someone who truly models computational behavioural science. Yoshi is a leading figure, not just nationally but internationally, in the quantitative analysis of behaviour, society and culture at all levels, and he's going to tell us, I think, about how you do that. And many of those present know Yoshi and love Yoshi, but for those who don't yet, I'll say a little bit about his background. You may not know that he started off training as a lawyer in his native Japan. I think what a loss to our field it would have been had he stayed behind some desk in a suit working for Toyota or something like that. Somehow I think it would not have worked out very well. He then went on, after seeing the light and becoming a psychologist, to study at the University of California, Santa Cruz, which some of you may know has a banana slug as its mascot, and then on to the University of Illinois at Urbana-Champaign, which is one of the great centres for social psychology. He came back to Australia, or came to Australia I should say, taught at UQ for a while, taught at La Trobe for a while, but he's been with us here for close to 2 decades. Yoshi's best known for his work on cultural dynamics, and he's really been a leader there. And he is, without any doubt at all, this nation's premier psychologist of culture ever. But I think his hallmark really is his incredible intellectual breadth. We try to be intellectuals here, not just psychologists, and Yoshi's really a model of that. He is probably the only social psychologist in the world, I would guess, or one of very few, who's also published in physics journals. He does work on sustainability. He does work on utopian thinking. He does work on health behaviour change, how you craft better messages to stop people smoking, for instance. He does work on gene-culture interactions, close relationships, emotions. If anyone's looked at Find an Expert, and you see the map of science, which provides this two-dimensional space where all of human knowledge can be fit, and you look at Yoshi's profile, it looks as if someone has sneezed in multicolours all over the field, because he's got publications in pretty much every area you can think about. Yoshi's received numerous prizes. He's become a Fellow of the Academy of the Social Sciences in Australia. He's won the Gordon Allport Intergroup Relations Prize. He's been a past president of the International Association of Cross-Cultural Psychology. He's played editorial roles on many of our field's major journals. He's won ARC grants with enviable frequency and published highly prolifically. Please make welcome my good friend and very esteemed colleague, Yoshi Kashima.
Thank you very, very much, Nick, for that very generous introduction, and everybody else for being here, and my dear friend, for setting this up, and give me a chance to embarrass myself. But anyway, and Pip, she was the reason why I came to this university, I must say. When I first came over here and had a conversation with her, well, I applied for this job because of you. And it is a great honor to be able to give this a talk. And thank you. Right. this point in our history, I think we are facing a number of challenges, starting from climate change and many of the health issues, including obesity and mental health problems, and also a political polarization, extremitization, and perhaps radicalization, and sometimes even terrorism. These are the challenges that face us today in this century. And we're kind of baffled and wondering how we can address so many of these problems. Well, we're scientists, right? And we really have to sit back and think about it as a problem solving. It is a problem, or a bunch of problems, and we have to think about ways of solving them. How do we usually do it? We actually first notice problems, right? And then think back, what might be the causal structure of the world that has given rise to this problem? And then we theorize and come up with some kind of a solution and eventually try to apply that to the world and solve it. Well, let's say this is a fairly simple-minded approach to problem solving. And if you think like a good scientist and think about these problems, actually there are two things that strike me as really, really fundamental. One is that those three problems, as if I talked about them as if they are different things, and oftentimes we treat them in the country and bureaucracy and politics as if they're completely separate, independent problems, but in fact they are completely interdependent. So there's plenty of evidence to suggest that the global warming and the rising temperature is going to increase aggression and conflict. And there's enough evidence to suggest that that's going to be happening, especially in the global tropics. Think about climate and health. Right? There's plenty of evidence to suggest that the warming temperature and other associated weather events are going to dampen our health. It's going to cause a lot of problems, and you can see how the labor capacity, our ability to work, is going to be decreasing as the amount of extreme weather events go up. Not to mention many of those problems associated with the unknown or rare viruses or the microbes, like Zika or Ebola. What sort of health problems do we encounter as the climate warms? Is anybody's guess. And of course, health and conflict are going to be related, right? It's simple. If you have physical conflict, of course, that's not going to be good for your health, right? But even psychological conflicts are going to cause stress and health issues. So all these three things are in fact interdependent problems. And worst of all these problems are going to be really concentrated around that global tropics, just off the north coast of our continent. The other thing that comes to my mind is that actually this is a problem that many of those problems are caused by humans. Let's step back and think about it. The humans, modern humans, anatomically modern human, Homo sapiens, came out of East Africa, that's our currently dominant theory, and spread around the world. And in doing so, we have been constructing our own niche. And a human niche that we have created has been so successful for us that we managed to spread around the world. And it has been the major way in which we have been so well adapted to this planet. So we create niche, modify the environment, and we live in it. And that's how we manage to live in so many different places, even in Antarctica, with the help of science. But when we talk about the human-made niche and the environment, In fact, it's not just the built environment. It's not the physical built environment that we create, but also we create social environment and psychological environment. And many of the social institutions are set up to construct those human niche in such a way that it is comfortable for us. Just like beavers create their dams, we humans create our niches, and that's how we adapt. However, we've been too successful. So some call the present as a time period, a geological epoch, proposing to call it the Anthropocene. The reason why is that the human activities can no longer be just considered to be just one species activities. It's altering the whole of the planetary system. The details don't matter, but you can see that the red lines or red areas are all going up as the time goes on. They are including temperature, global temperature, CO2 concentration, and ocean acidification, and many, many more. Those are the indicators of chemicals and other sorts of indicators of the biosphere that is being very, very stretched. And sorry, I was going to show you this. There are really two boundaries that such a successful human niche construction has been threatening to breach. One is the planetary boundaries of those temperature, ocean acidification, and many of those ecological boundaries. But the other is a societal boundary or human boundary. And that is to say, we are producing a poor and global poor. And the difference between the richest and the poorest is increasing. And we are threatening to breach that bottom line that we ought to be keeping for all of humanity. So, how can we address these challenges? And given this kind of rather sketchy analysis, it should be fairly clear that at the center of many of these problems that we mentioned, climate change, health, and the national security, that's human behavior. Human behavior is at the core of it. And in order to address it, we really have to understand, explain, predict, and especially influence human behaviors in such a way that we can have a more sustainable future for the environment as well as for humanity. And oops, it's going too far. And it is true that we citizens, individual citizens, will have to be doing something for it. Certainly, we can have our ethical standards, our moral reasoning, and we can look after each other. That's fine, true, and we ought to be doing that. But we definitely need to have governments or other sorts of public institutions to be intervening and try to maintain this or sustain the possibility for the future. Right, so the problem-solving cycle we alluded to. Once we bring in the government and the public discourse and policies, that becomes a lot more complicated. We have to be engaged with the public discourse, and there's a political processes involved, and there's a policy cycle that has to be engaged. All these things have to be somehow managed to be able to make ideas work into the real world. That's necessary because the problems are so large and so interdependent. And the Australian Public Service Commission agrees with us. So how democratic governments can most effectively influence the behavior of their citizens for the betterment of the society. And they say, well, we've been managing quite a bit, but we need more. And so, why? Because those problems are so-called wicked problems, not just tame and simple problems. Wicked problems, according to Australian Public Service Commission, is very complex problems that go beyond the capacity of any one organisation to understand and respond to. And there's often disagreement about the causes of the problems and the best way to tackle them. And they list 4 examples: climate change, obesity, indigenous disadvantage, and land degradation. What are the characteristics of these wicked problems? Well, they list quite a few. Wicked problems are difficult to clearly define and not very stable, not clear solutions are on offer, and socially complex, and hardly ever sit conveniently within the responsibility of any one organisation, read department. And some wicked problems are characterised by chronic policy failures. Well, we've seen that. We have been seeing it, especially in climate change area. And look at this. They acknowledge that wicked problems involve changing behaviour. Graham Sheffer, a professor in engineering, when I was talking with him, he said, well, many of these things have engineering solutions, he said, but throw in humans and it becomes a wicked problem. And they agree, I agree. Human behaviours are probably a problem, but also a solution. We have to make sure that humans are engaged with the problem solving. Anyway, the wicked problems has many interdependencies and are often multi-causal. Pretty complicated. And attempts to address wicked problems often lead to unforeseen consequences. You might try to do something and it comes around and knock you down from behind. So, wicked problems. And actually this phrase was coined by Ritter and Weber nearly half a century ago. And he said this, they said this: the search for scientific basis of confronting problems of social policies bound to fail, because they, that is scientific basis, are weak. These policy problems are wicked problems, whereas science has developed to deal with tame problems. So they charge us that you guys are dealing with tame problems, the easy ones. Now we have more complex and wicked problems, and you're not going to be able to solve it. Well, that I think is a challenge. And of course, we have to live up to that. Right. Actually, Australian Public Service Commission mentioned a variety of the traditional methods to deal with the wicked problems and behaviour change problems. And in my reckoning, there are basically 3 different classes of behaviour change interventions. And the 2 are really, really traditional. So one is the rules and regulations. You tell people to do this or not to do that, and if people fail to do that, well then they punish you, right? Rules and punishment. The second one is the economic incentives. Set fiscal and monetary policies so that there are certain incentives or costs, so that the people would think rationally and say, right, that's too costly, I won't do it, or that's rewarding, so I will do it. Those 2 have been around, but actually the problem there was that we need to have a third approach. Those 2 traditional ones really need to be dealt with. So the third one is, I think, a change and the intervention into affordance. And that's what behaviour scientists mostly do. Let me try to explain what I mean by that. So the affordance is the concept that James Gibson came up with many decades ago, and he had been working on, and he was a perception researcher. But so to give you an example, coffee mug has a certain affordance. so that you can actually hang on to it and grasp it. So the handle on the coffee mug forces you to grasp it. The chair has a certain physical structure so that it affords you to sit on. So anything in the world has a certain affordance for an organism to do something. Oops, I think this is, sorry. I think it is stuck. Previous, right. So likewise, we could intervene into the environment so that the people see an affordance of behavior. So one example is to paint footsteps on the floor, and that affords you to step on it and walk along, and also paint the stairs with the black and white piano keys, and they afford you to step on it and walk up rather than taking the escalator. So in these sorts of simple things can actually influence human behaviors. Not always, or for a long time, but certainly at least momentarily. Another great example comes from these defaults. So you can set the certain policy set in such a way that the default is a desired behavior. So this is a case of organ donation. And if you look at the European countries, there are countries that have almost 100% organ donation agreement, whereas others have much lower. And why would that be? Well, Johnson and Goldstein thought that actually this is the way the organ donation decision is framed. So in those countries, like Sweden, where the organ donation rate is nearly 90%, the organ donation is a default. And people can opt out of it if you want to, but many people don't bother to do that. And on the other hand, other countries like Germany and the Netherlands, the default was, at the time anyway, to opt in. So default is not to donate organs, but you can opt in to do so. Then many people don't. So in order to say, well, perhaps that's something to do with the actual organ donation decisions, and then they run the online experiment, 3 conditions, compare the 3, and it is indeed the case that if the decision is framed as an opt-in, people don't do that too often, but if it is opt-out, most of the people say, yes, I'm happy to donate organ. Right, so stepping back and think a little bit more, well, this is, I think, is the models of the person in behavior change. So the underlying model, I think, is the one of self-regulation. Human being is driven towards a goal, and but along the way we perform behaviors and get some feedback and make some changes and try to achieve the goal that's desired. It's been around for a long, long time, and part and parcel of much of the behavior science thinking. But and then we can say that perhaps there are other ways in which we can intervene into this decision maker or a behaving person and the actor. And that is to give a rule and then threat with punishment, right? So that's the most traditional one that's been around for thousands of years. Another one is to give incentives, and so that you can change the outcome and goal structure so that people would behave differently. But what we are saying is that there are other ways of doing it, and that's to change affordances. And good examples are collected by Thaler and Sunstein in their book called Nudge. And they say that all these things that I'm calling the affordance is really about changing the choice architecture. I would agree with that, but probably there are more broader range of things. And especially what they're missing is the notion, the other half of the notion of affordance. Affordance is a relational construct. It's influenced by the environmental structure, just like they say it is a choice architecture that can be changed to influence behavior. But also, it's changed by the human capabilities, what people are able to do. And by building capacities and empowering people, they can change their behavior as well. So, behavior sciences. I think in these sorts of ways, the traditional behavior science have delivered quite a bit, especially in Australia. The people involved here as well, I'm pretty sure, there you go, Ron, and many of his colleagues have been very successful in influencing the smokers' behaviors. There have been ups and downs, but certainly they have been managing to do that. SunSmart campaign is another great example. It's been so successful. Probably needs to be revamped again, but still it's been a success story. Another one coming from the UK, increasing the UK private pension membership from 2.7 to 8.8 million over 5 years. And this is a great achievement. Any of these things have been done by traditional behavioral science. It's been great. But the world has become, and perhaps always have been, a lot more complex. So take an example of climate change. And somebody might come up with a brilliant idea. Well, let's say encourage people to buy solar panels. We can reduce carbon emissions, and that'll be fantastic. Well, that might be so. But looking at it from the individual householder's perspective, actually, solar panels is only one of the many things that they might consider doing in order to reduce carbon footprints, and one of the most expensive ones. Other simpler ones are possible, like setting milder temperature. So, instead of setting 20 in the winter, perhaps they reduce it to 19 or 18. That'll reduce the energy consumption, certainly. We can buy carbon offset or green power, or perhaps we can buy much more energy efficient appliances like fridge and washing machine and so on, and solar panels is just one of them. And in fact, if you look at the pattern of behaviors, those behaviors are not completely independent of each other. They are not independent choices. If somebody does one of those things, those linked ones tend to be done as well. So that is there's actually interdependence and correlation in the world. And so these are kind of behavior clusters. And if you intervene into one of them, let's say solar panels. Let's say you buy solar panels. It could have repercussions. Well, it might encourage you to get the solar water system. That might be great, but there could be a negative impact as well. So, for instance, there's a bit of evidence to suggest that some people, after putting up the solar panels on the roof, they say, oh, now I can have clean energy, or my energy bill is going to be much lower, so I can use aircon as much as I want. Well, that way you can possibly put more pressure on the grid and perhaps potentially increasing the energy consumption. So all these sorts of complexities are there, and we really need to think more about. Now, this is just one single individual person and deciding what to do. But if you think about the household, this gets to be even more complicated, right? So imagine that there's a household of 3 people, each of whom has some behavior configurations. And here's the mother and the father, and here's a teenage son. And that complicates things, right? And the mother says, oh, right, let's set the temperature to 18. It's going to be great. We'll be doing something for the environment. And the father might agree, sure, that'll reduce my energy bill, so that's wonderful. And then wait until the teenage son comes back and says, no way, Jose, I'm going to be wearing my T-shirt all the winter. And I'd love to have the 23 temperature in my house. Well, you might be able to convince one child, but if the kid is embedded in a network of his mates were all committed to be wearing a T-shirt throughout the winter. Well, I'm not going to bet on your luck. Imagine now you have many, many communities like that, and they are all connected by different sorts of interpersonal networks through even the digital world. All that communication is going to complicate a lot of the flow of information and social influence. And imagine something like that. Well, I'm not suggesting that there are going to be two camps of people who are setting the temperature to 18 and 23, but you know where this comes from, right? It's a red team and blue team from the United States with Twitter. All right, so there's a complexity and dynamic agency and sociality involved, and we really need to deal with this complexity and embrace it. And without understanding this, any sort of a behavior change is going to be a trouble. So I think we really need to bring together a better conceptual and technological tools like computational behavioral science to deal with this complex issue. We really like to bring methodological tools and technology from big data and data science and marry them and integrate them with the great theoretical insights from the behavioral sciences, and they manage this difficult, wicked problem. So where does this computational behavioral science come from? And I'm going to rush through this very, very quickly. I'm sorry, but so its roots really comes from behavioral science, and it emerged in the 50s after the World War II, at the beginning of the the Cold War. And the people like Alex Barbelas, probably if you have been doing some communication research or social network research, you might have come across his name. He set up the communication lab in MIT, and eventually it became a very important force in the University of Michigan. And another famous guy is Anatole Rappaport. He sort of brought the game theory into behavioral science, and famous for tit-for-tat strategy in the Axelrod's tournament. But less well-known is his contribution to information diffusion. In the biological science, I didn't read it, but I saw the paper, and it's definitely there. So these sorts of people have been involved in the building of behavioral science, and actually both of them were on the editorial board and signatories of the journal called Behaviour Science that was established in '58. But the force came from this guy, Bernard Berelson. Here's the public opinion researcher, eventually became the Stanford professor, and got lots of funding from Ford Foundation. That gave the impetus. It was short-lived, only a few years, but that allowed him to establish the Center for Advanced Study in the Behavioral Science at Stanford, and also to disperse this funding to a variety of research projects, including to those people. And there's another intellectual input coming from Kurt Lewin. If you're a social psychologist, you probably know him. I know of him. I've never met him. Anyway, so he's one of the intellectual great-grandfathers, I guess, of the modern social psychology. So those are the roots, and the important concepts like the behavior science, and information, systems thinking, and the notion of rationality. Human mind could be rational, and following the subjective expected utility models in decision-making, or perhaps game theory. These sorts of things have been put on the table. And of course, anthropology, sociology, psychology, political science, many, many social science disciplines bought these things, and they tried to develop it. Interestingly, economics kind of span out of it and have never been part of it. Do you recognize those faces? it'll be interesting how many you can actually name. And they ended up in this particular rabbit hole called Homo economicus. But all the way, the other social science disciplines have been moving forward. And I would like to say that one of the branches of this great intellectual tradition is what we might call computational behavioral science. Who are the contributors? Well, a variety of anthropologists, cognitive scientists have been contributing to the thinking about how human mind works and the meaning and cognition are dealt with. Networks. You probably recognize, some of you definitely recognize this man, Harrison White, and those two, I'm sure many of you can recognize. And the behavioral and empirical side of economics were brought in by, really, these two men have been very, very influential. But bringing them all together, and now we have this computational behavioral science, or so I would like to argue. And of course, Pip, thank you. So, what are the differences? Well, to cut the story short, I would say that the behavioral science has been very static and pretty much a kind of a cut and dried rationality based. But the computational behavioral science has actually embraced the complexity and dynamism. And we have gone from a kind of static, the rational solution to a problem to a more dynamic adaptation to the problems of the world. And how do we cope with those? That has become the focus of the research. And so its potential, the computational behavioral science, I'd like to argue that it has a great potential in both theory and methodology. And quickly, I'll go through them. So first about theory. Well, this is a policy, the problem-solving cycle that I alluded to first. And any good science will have to take out the theory and methods, bring them together to solve some sort of substantive issues. And it is that bringing together of theory and methods that allow us to construct the research project and program and apply it to the substance. So this is the behavioral science, the computational behavioral science, and the theory part. This is an example, and of course there are many other ways, but I'd like to pick this one because it really sort of highlights the complexity of the issues in behavior change research. So I alluded to the possibility that intervening into the solar panels, the purchase, might have some repercussions. But there could be a positive side too, in that if somebody begins to do something easy, say setting the temperature at 18, and then it might spill over to other things, more difficult or perhaps more expensive things, but nonetheless it might drive you all the way to solar panels, for instance. And this is called spillover, positive spillover effect. But then again, solar panels purchase might have a negative spillover effect, possibly. So all this complexity needs to be understood and somehow explained, and also, if possible, modeled and predicted before we intervene. And this kind of complex network, if you like, of interdependent behaviors have been thought about in the behavioral science area. And Johan, I don't know if he's there or not, he sort of showed me that one of his mentors, old publication really is addressing that. But more recently, there's been a lot of talk about symptom networks and how different symptoms in psychopathology might be correlated with each other. And rather than there's an underlying latent illness, if you like, there is possibly just a correlated symptoms, and that's what this psychopathology might be. An interesting ontology. And of course, it's been applied to various areas, including cognitive science, and also a personality as well. So these sorts of ideas that an actor's various attributes, like behaviors, cognitions, meanings, etc., are highly interdependent and correlated with each other, and that might produce a complexity, but nonetheless an interesting phenomena to look at, and that's been around now. And there have been many approaches to this kind of situation where, in fact, each person might be thought of as a network of attributes. And those networked attributes are also networked by social networks. So then this is the networked networks. And there have been many approaches as well. And very recently, we heard a talk from Nikita Basov, who is making a very interesting contribution to the modeling of socio-semantic networks. So when you have a situation where the whole of society can be thought of as a network to networks, well, then the behavior change intervention takes on a rather complex picture. Does a behavior change intervention have impact? Does it diffuse over social networks? One person changes behavior, his neighborhood neighbor might change as well. And then if it happens, how does it happen? How fast does it travel? And how far would it diffuse? All these are interesting and difficult questions. And on top of it, would there be positive or negative spillover effects? Your intervention might have unforeseen consequences. And this is one of the Friedkin's model of social influence. I'm not going to go into the details of it. It allows you to think about how social influence processes might produce overall consensus, or perhaps a polarization of attitudes and beliefs. And this is a new emerging areas of research. So, diffusion in a networked networks. And once you have something going, we can perhaps model it. And its further diffusion might be modeled through networks. And then we can construct the models to look at the overall macro level dynamics of it and analyze it in different ways. And once these sorts of macro level phenomena emerges, well, its impact on the individual needs to be thought about, but I think we can do that as well. And that is really the categorization process. Okay. So that's the theory and possible development that we can pursue. It's also the methodology of the new science that perhaps that help us to get to our goal. So the big data and AI, probably everybody's on mind. This is on everybody's mind. And of course, the digital trace data, it's sometimes called, it's a human behavior and it's trace. That is leaving some sort of information about what the person has done. And that is now aggregated into big data, and we can use a variety of techniques in the current AI, including deep learning and other sorts of machine learning techniques, and more broadly computer sciences, the developments. And so that we can observe, or at least make inferences about the human behaviors on large scale. But big data and AI are useful, but it's got some problems as well. So privacy concerns is always there, and I don't have to elaborate on it. And there could be validity issues. I'm not saying that the big data are useless. Certainly they are extremely useful, and we have to embrace that. But nonetheless, the traditional issues of validity and reliability of behavior measurement is not going to go away. It will be staying with us. And it's become even more complicated. A good example is this, the Google flu trends. It's a big data-based approach to predicting how much of a flu is going to be influencing the US population. Cutting the long story short, it really overshot in 1 year. And caught the Google in red face. There have been many reasons, and David Lazar gave a very informed analysis of why this might be has occurred. But the one thing that he said that really caught my eye, he calls it the big data hubris. And basically, he's saying that the big data does a very good job and had done a very good job of predicting the flu. But if it's combined with the more traditional data and use that in a time-lagged way, the combination of the two is extremely, extremely good. Use both, and we can get a much better prediction. So we shouldn't be just embracing the big data, but we should be able to make use of the traditional method of data collection and analysis. And don't forget reliability and validity that you have learned in the first year of psychology. So we have this causal structure, and we bring data to it. So there's a data generation process, and we observe it, and make sense of it using theories. And that's been what we've been doing all the way through in many of the social science disciplines. But because of this new development, the data generation process has become a little more complicated. We are much more used to setting up the methods so that we can observe the things that we are interested in. We construct the apparatus for observation. So we know exactly what the data generation process is. But in this digital trace data, we don't have much control over it. Actually, data are collected not for the research purpose, but for something else. They have their own agenda, and we have no control, or sometimes no control whatsoever. Sometimes we might have some control, but we probably should be trying to have a dialogue with these sorts of people so that we can gain better and more useful data for us. But anyway, so this complication has caused too many problems. Well, once we have the causal theory, then, of course, we have to come up with the innovative ideas to intervene into the, into the causal world. And of course, we have to operationalize it. I know you don't like the word operationalize, scary, but I'm going to use it, and I'll defend it if you like. But and then intervene into the causal structure of the world so that we can change it. Right? Okay, and as I said, the validity issue is paramount in both ways. And it's interesting that the Bosborn, actually, he is the one who's sort of been talking about this, the attribute networks or symptom networks. He published a paper in Psych Review he made an argument that actually the notion of validity really needs to be thought more in terms of causality. And so we are measuring things. The valid measure is something that is caused by the construct of interest in the world. So there has to be some causal mapping between the measurement and the causal structure of the world. And likewise, I would argue that your intervention has to have the correspondence to the mechanism in the world. Both ways, measurement and intervention, both of them have to have the causal mapping, and that's what the validity should be. Right. And perhaps what we can do is to create something like a policy playpen, right? We construct something smaller that is perhaps modeling or mirroring, or perhaps bringing out the most important elements of that real-world structure. And the experiment. Of course, there are many experimentation techniques we know. The traditional method or randomized control trial, or perhaps we better know it as a field experiment, the same thing, or modeling. And what computational behavioral science can do is to improve the capacity for modeling and simulating and forecasting, but also giving us a better tool for doing field experiment, a lot better than before. And so we create a playpen, and we spin them around so that we can produce a better solution. because it is a Playpen, we can afford to fail. And in fact, Popper famously said, a hypothesis can die in our stead. And very much so, the Playpen can die in our stead, but in the end, policy might be better off. So it's a promise of the computational behavioral science is to bring together these sorts of methods and theories, and you contribute to the public discourse as well as to policy cycle, so we can better inform the solution to the problem. And we should be widening the bottleneck. That is, we have to be able to translate this kind of knowledge to the real practitioners who are trying to solve the problems. And also, we need to be creating the capacity to be able to do that. So we should be doing both of them in the future so that we can bring about a healthy, sustainable, and safe society. And thank you very much.